The basic question I want to discuss is whether reference pricing in the pharmaceutical market is a good or bad thing. So reference pricing, good or bad? And the answer is going to be that it's a good thing because reference pricing will actually reduce pharmaceutical prices both for the branded drug and for the generic drug. So it's good because it decreases prices. Prices go down. But in order to show this, we need a model. So in this model, and this is not a model I developed myself, this is a model developed by Brecke and published in the Journal of Public Economics in 2011. So in this model, we're going to have, first of all, a situation with no regulation, and then we're going to have a situation with a price cap, basically a maximum price that they're allowed to take for the pharmaceutical. And finally, we're going to have a situation with reference pricing. And reference pricing in this system means that the government will set a price that they're willing to reimburse, and the consumer will have to pay the difference between that price and whatever price the company will take for the drugs. Reference pricing. And the price the government will set is based on the price of drugs in general. So that's why we call it the reference price. We have a reference group of drugs we use to price the new drugs. Now we're going to develop two systems or two models of reference pricing here. First, we're going to discuss exogenous reference pricing, meaning that the companies that will just set their price without thinking that the price they set actually feeds back into the reference price that the government uses. And then we're going to have endogenous reference pricing, meaning that when the companies set their price of the products, they have to consider the fact that their price will actually affect the reference price in the next period. Okay, now the basic conclusions we're going to find will be that when you have no regulation, then you have a price of a generic drug and the price of a, let's say take the price of the branded drugs first. The price of the branded drug, and you have the price of the generic drug, and it turns out that if they increase the price of the branded drug, that will also increase the price of the generic drug. It's almost like when you have Pepsi and Coke. If Pepsi increases their price, then of course Coke could also increase their price because they face less price competition. Now if you have a price cap, that means the branded drug will have a fixed price. Of course you will have a lower price than when you do not have regulation. And it will also be the case that if you increase the price of the branded drug, then the price of the generic should go up. But if the price cap is low enough, then the market for generics will be very small. Now the interesting thing is, if you have reference pricing, what will happen? Well, of course, reference pricing again will mean lower prices than no regulation, but higher prices than price cap, depending a little bit on exactly where the price is. But now you're allowed to take more higher prices because the consumer will have to pay the difference. But the important thing is that if the branded, so you have lower prices, but when you get lower prices, what will happen for the branded drugs? What will happen to the price of generics? Price of generics. And it used to be the case that people believe that the price of generics will go up, the convergence hypothesis, because if you have a reference price, so let's say R, that's the price that you get reimbursed, then the branded drug will be more expensive and they will face a pressure to go towards R. But the generics, of course, if they have a lower price than what is reimbursed, they could actually increase the price. There's no pressure to have a even lower price than what is reimbursed. So the price of generic drugs, they believed, would go up, but the price of the branded drug would go down. That was the basic theory. But then this paper came and it said that, wait a second, maybe the price of the branded drug will go down. But if you actually consider the fact that if you are the generic company here, and if you actually increase your price, then that will lead the reserve reimbursement price to be higher in the next period. And a higher reimbursement will lead more people to go to the branded drug. So you will be careful. And they actually show that this effect, if you consider this effect, then the price of the generic drug, the optimal strategy will actually be to decrease the price. So they have a theory here, and they also have some empirical information because in Norway, we had some drugs that actually had a reference price system and some drugs that had a price cap system, and they could actually observe the differences in the prices, what happened to the prices of different pharmaceuticals. Okay, so that's the basic story. Now, the more formal story would be the following. In order to develop this story, we need some behavior, and we develop this based on maximizing behavior. So the consumers will maximize their utility, and the companies will maximize their profit, and we'll see what happens to equilibrium price and demand and things like that when this happens. Okay, so the consumers will maximize their utility. What is their utility to the consumers? The utility will be, let's assume that the utility, if you take the branded drug, for example, is, and let's say that people believe that the branded drug is slightly better than the generic drug. It doesn't matter whether it actually is, let's just say they believe it is. So you have theta. And theta here is assumed to be the quality difference between the branded drug and the generic drug. So theta should be higher than 1. Say theta is equal to 1.2. That means that they believe that the branded drug is 20% better than the generic drug. But then you also have, so that's the quality difference. But then you have tau, which is the generic, which is the general benefit you get from using the drug. And you can assume that this benefit actually varies. So we're going to assume that some people will have zero benefit and some people will have the maximum will be t. So tau is distributed between 0 and t. Some people get zero benefit, some people get maximum benefit, which is t. And we're going to assume this has a uniform distribution between 0 and t. Okay? So there's going to be equal number of people with zero benefit as with maximum benefit t. Okay. So the benefit you get if you take the branded drug is going to be this theta times tau, and then you're going to subtract the cost of the branded drug. Same if you take the generic drug. Utility of taking the generic drug is, now you don't have a quality difference here. You just get tau. And then you subtract the cost of the generic drug. Now notice that if you want to find out how many people actually take the branded drugs, that's going to be the people who actually benefit from taking drug, of course. So how many people will take the branded drugs and how many people will take the generic drugs? In order to work out that, find the person or find a limit where people are indifferent between taking the branded drug and the generic drug. Utility of the branded drug is equal to the utility of the generic drug. If you can find that point, that's going to be when theta tau subtract c branded drug is equal to tau subtract the cost of the generic drug. And if you work out this, then it's going to give you when tau is equal to the cost of the branded drug subtract the cost of the So for tau here, for a person who actually values a drug this much, then given that the price difference between the branded drug and the generic drug is this much, and the quality difference, perceived quality difference is theta here, then we know exactly the value that will distinguish between the people who want the branded drugs and the generic drugs. And you can see that from, if you go back to this figure here up on top, you can see if people value the drug highly, let's say they value it up here. Let's say this is tau, the limit. Now, if they value the drug here, then the people who value it even more, they will buy the branded drug. The people with high valuation of drug will buy the branded drug, but all the people down here, they will buy the generic drug. Or you could have some people not buying the drug at all, of course. So now we have a distinction between, we can find a demand for the different drugs based on this, which all the people who have more will buy the branded drugs, and people less will buy the generic drug. Slightly more formally, you could do this. Say the demand for the branded drug, and that's going to be equal to either 0 or 1 or something in between. And it's going to be 0 if the cost of buying the drug, the marginal cost of buying the drug, is bigger than the maximum utility you could actually get from buying that drug. And the maximum utility you could get is up here for those who have T, right? That's the maximum. Those are the people who value the drug the most. So that means the utility difference then between the brand drug and the generic drug will be so if the cost difference between the brand drugs and the generic drug is bigger than the utility difference, you will not buy the branded drugs. No one will buy it because even for those who value it most, the cost difference is bigger than the utility difference. And of course, if the cost of the branded drug is smaller or equal to the cost of the generic drug, everyone will buy the branded drug. Now, the interesting thing is, of course, in between here. And I just said that this here will be, we can take this as the area here represents how many people will actually buy the branded drug. And that's quite easy to work out what this area is actually, because if we standardize the population to 1, so this whole thing is going to be equal to 1 here. And we know this is T, so this has the height of this curve has to be 1 over T. So in order to work out the area of this, the area here, we just have to take 1 over T and multiply by T subtract tau. That's going to be the demand, given that the price, or the difference here between the price difference between the two drugs is in between here. So some people, the price difference is such that some people at least will find it valuable to buy it. So that's how you work out the demand for the branded drugs. And then you can work out the demand for the generic drug the same way basically, but now you're working out this area. And I'm going to leave that as an exercise. Okay, given that you know the demand here, what can I do? The question is, what happens to prices, of course. So what happens to prices? Well, given that the companies know that the consumers will behave in this way, they will have these demand functions. And given that you also know that the companies will have to maximize their profit. So you say the companies will have to maximize their profit, and the profit is going to be equal to the price of the drug, subtract the cost, let's call that W, that's the price, that's the cost, and you multiply that by the demand for the drug. And then you do that for the branded drug and you do that for the generic drug. So that's the profit maximization function. And then you have to make some assumptions about the market structure, so and how they determine prices and things like that. So let's say they determine prices simultaneously. And what you do then is we're not going to do this formally here, but you take the first derivatives and things like that, and you find the reaction functions, basically how you will set your price depending on how the other person will set their price, or how the other company will set their price. And at some point, these reaction functions, your adjustment of your price, will find a stable point. You will have set a price, and the other person or the other company will have a price, and you'll both be happy with that price. It'll maximize your profit. You can't get a higher profit by increasing or decreasing your price. Okay, so you will get a price for the branded drug, and you'll get a price for the generic drug based on this maximization function here now, reaction functions. Okay. And what they show in this paper now, first under no regulation, is that, so no regulation, 1. They show that prices are complements. They show that if the price of the branded drug goes up, then the price of the generic drug also goes up. And that's as I said, easy to understand. If the price of Coke goes up, then the price of Pepsi will also go up because they face less price competition. Now, the second thing is on their reference pricing. Sorry, not reference pricing. If you have price cap, then basically you set a maximum price for the brand drug. And again, then this will be lower, of course, than when you have no regulation. But if this and this will actually drive the price of, so the price of the brand drug will go down, but it will also drive the price of the generic down a little bit, or it could, because they face higher, tougher competition. When the branded drug, when the price of the brand drug goes down, they will face tougher competition. They may actually face, if the price cap is low enough, you will eliminate the market for generics. No one will buy that because they might as well buy the branded drug. So that's easy to understand. Now, then the price will go down compared to no regulation. Price of the branded drug will go down. Basically because when you put a reference price here, then it becomes very expensive for the consumers to pay something that is a higher cost than a reference price. So that will give them some competition here, basically, or give them some pressure to reduce their prices. But for the for the generic drug, they face very little pressure because if you get reimbursed more than your price, if the consumers get reimbursed, there is no incentive to actually have a lower price than the reference price. So assuming that the reference price is somewhere between the branded drug and the generic drug, they will have an incentive actually to increase their price. And that's a standard theory. But, and that's the important thing here, they actually show in this paper that the price of the branded drugs will go down as expected when you have endogenous pricing, meaning that when the companies actually consider the fact that my price, the price I set, will actually affect the price that the reimbursement here that the government will set in the next period, because it's based on an average between the branded drug and the generic drug, for example. So after they have set their prices, and the next time period, the government will actually calculate a new reference price. And if they actually consider that before they set their prices, then still it's the case that the company producing the brand drug, they will have an incentive to reduce their price. But the company producing the generic product, they will think, if I set my price up, then I will actually help the brand company because they will face less pressure with a high reference price. So maybe I should instead take the price down in order to capture a larger market share, because if I set the price down, that will actually reduce the reference price, And when you reduce the reference price, they will face stiffer competition here. And they actually show this formally that this is true. This is the incentive structure is such that it's profit maximization that will lead these companies to actually decrease their price. Both companies will decrease the price under reference pricing. So that's the important difference there. If you have exogenous reference pricing, if you believe that theory, then they will have an incentive to increase their price. But if you have endogenous reference pricing, they will have an incentive to decrease their price overall. And they prove this in his paper. Now, what happens empirically? Well, in one survey in Norway, when we actually had reference pricing for some drugs and price caps for some other drugs, they show the following. They find that the prices went down for both the branded drugs and the generic drugs, and for those drugs that were subject to reference pricing, the price of the branded drugs fell by 23%, and the price of the generic drugs also fell by 13%. Down. And some of the drugs actually had price caps in the same periods. And it turns out that the price fell by 8.5% for the branded drugs and 0% for the generic drugs. So that's why they believe that this theory that both prices will fall is accurate. And that's why reference pricing, one might argue based on this that it seems like to be a good idea. Now, of course, there are many other factors here, but this is just one model and I want to present that. Thanks.